This lesson is going to be on file permissions and ownerships. So, for file permissions, this will actually allow you to restrict who has access to a file, who can run a file, who can read the file, who can write to a file, based off of a user's name or a user's group, or anything for that matter. So let's go ahead and start by discussing how we can see permissions on a file. To see the permissions on any file or directory, we could simply just use the ls command -l for long format. This would allow you to see all the permissions for any of the files within the current directory that we're currently in. So right now you'll see that we're in the root directory, and you'll see that all of these different folders have a different set of permissions. So let's go ahead and talk about what each of these permissions are. Let's go ahead and go to our home directory first. ls-l, perfect. So let's create a new file. We're going to call it test file. If we do ls-l, let's do ls-ld on the test file.txt, you'll see that the permissions for this file are set to -rw -r-r-. Now in order to read this, you need to know what each one of these bits mean. Permissions are broken down into a series of 10 bits. The first bit being the file type. So notice for this desktop folder, the first bit is the letter D. D stands for directory. So this is letting you know that this file is a directory. The dash means that it's just a normal file. So whenever you see a dash as the first bit, you know that this is just a normal file. And then we have the next set of bits, which are broken down into 3 bits, or groups of 3. So we have RWX, which stands for read, write, execute, R-X, which is read and execute, and R-X, which is read and execute. Now the first set of bits is RWX, and this is for the actual owner of this file. So notice that the owner for this file is root. So root can actually read, write, and execute. So that means root could actually go into this folder, read what's in the folder, execute the folder, and write to the folder. If you look at the next series of bits, R-X, you'll see that it's only read and execute. The dash means nothing. That means that the group members do not have permission to write to this folder. And then we have the last set of bits, R-X as well, which means anyone else, or other, which means that anybody that's not a part of this group, root, and is not the root user, can only read and execute what's in this folder, or read and execute the folder itself. Now when applying permissions to a folder, if you're going to give read permission, you need to give execute permissions. But for a file, you can actually give read or execute depending on what you want to do. For instance, let's say you created a script and you only wanted a user to be able to execute the script but not read what's in it. You could actually just give the execute permission to that file, and the user would only be allowed to execute that file. So you'll notice that when we created this test file.txt, the default values were read, write for the owner, read for the group members, and read for anybody else. Now each of these bits represents a different number. For instance, since they're broken down in 3s, you can think of it as 421, 421, 421. The R standing for 4, the W standing for 2, and the X standing for 1. So when you see read, write, execute, that represents the value of 7. 4 plus 2 plus 1 equals 7. When you see R-X, that represents 4 plus 1, 5. since there is no W, you just add an imaginary 0. And same for here. R plus X is 5. For this file, you'll see that it only has the R and the RW. So 4 plus 2 is 6. So you have your first permission, which is 6. Then you have the R, which is 4, and the other R, which is just 4. So let's say I wanted to change the permissions on my test file.txt, and I wanted anybody that's a part of this group or this user, I want to be able to read, write, and execute, but I don't want anybody else to be able to read, write, or execute it. So in order to do that, we would use the chmod, and with this utility we would actually be able to modify the permissions. For instance, so if we wanted the owner to be able to read, write, and execute, that would be 4 plus 2 plus 1, 7. We want the group to also be able to read, write, and execute, so read, write, execute. So 4 plus 2 plus 1, we have 7 again. And then we want everybody else just to not be able to read, write, or execute, so it would be 3 dashes, which would be 0 plus 0 plus 0, which is 0. And then you need to supply the file name. So now if you do ls-ld on that file, you'll see that the owner of the file can read, write, and execute. The group owner of the file can read, write, and execute as well. So let's go ahead and create some 2 test users, and we'll test out some of these permissions. So first I'm going to go ahead and create a folder, and I'll call it shared. And I'll put it as the root, so root shared. Well, let's create a group called shared also. So we'll do group add shared. And now we're going to create 2 users. So we're going to do user add -g. We're going to make the primary groups, let's say shared. And this will be user 1. And we'll do the same thing for user 2. I'm going to go into this next tab that I have open, and I'm going to log into user 1. And I'm going to go into the third tab I have open and log into user 2. So if we do an ID, you'll see that this user is actually a part of the group shared, but has its own username. So now let's view the permissions on the folder shared that we just created. ls-ld shared. And you'll see that the owner can read, write, and execute, the group can read and execute, and anybody else can read and execute. So let's change the group membership for this folder. To change the group membership of a folder, you can use one of 2 utilities. We could do chgroup, and with this would actually allow you to update the group permissions on a directory or file. So for instance, let's say we needed this directory to have the group of shared, and then you would just apply the path for shared. So now if we did ls-ld on shared, you'll see that this folder is actually owned by the group shared. And the group shared can actually read and execute. We're going to want to update that though to make it so the group can actually write to this directory. So let's just do that real quick. We're going to want the owner and the group to write, so that's 7-7, because we want read, write, execute on the owner, 4-2-1, and then we want read, write, execute on the group, which is also 4 plus 2 plus 1. And then we can actually give, for anybody else, 0. So nobody else can read from that folder. We would supply the path, and now if we did ls-ld on shared, you'll see that both the owner and the group now have full permissions to read, write, or execute to that folder. You can also use a different utility called chown, which is change owner. Now you can actually change the ownership, so change the username, who owns this folder or file type, and change the group at the same time. To simply just change the owner, we would just do chown space the username we want to change something to. So we'll do user1 space the file type that you're changing. So in this case it would be shared. So if we did ls-ld, you would see that user1 now owns this directory. Let's say you wanted to change the user and group at the same time, you could just simply do chown, and we'll do user1, which is the username, dot the group name on the shared directory. And this would actually change the information for that directory. Now instead of using a dot, you're also allowed to use a colon, which would have the exact same effect. So now that we have the directory set up with the permissions that we want, let's go ahead into user1, and we're going to create a file into that folder. So I'm going to create a sequence file for 100 numbers, and I'm going to redirect that into shared user1.txt. And I'll do the same for user2. So we'll do seq, but we'll do 1000 for user2. Redirect it to shared user2.txt. So if we go into our shared directory, do ls-ld or ls-l, you'll see that we have user1 and user2, so both of their files, where each file has its own set of permissions. Notice that user2 can read the file information from user1. So let's go ahead and do that. Let's go to user2. Let's go ahead and cd to shared, view the files, and let's say I wanted to view what was in the contents of user1. Since the permissions are for read for anybody else, or read if I'm a part of that group, then I should be able to read the contents of the file. So if I do user1.txt, you'll see that I get the series of numbers up to 100. Let's say user1 wanted to change let's go to the shared, and let's change the permission so that way no other user can actually read from the file or write from the file. So I would just do chmod, and then I want full control, so I'm going to give myself read, write, execute permission on user1 file. For the groups, I'm just going to give it 0, and for anybody else, I'm going to give it 0 as well. Apply it to my user1.txt. And now if I were user2 trying to read the contents of that file again, you'll see that it says permission denied. So along with these basic permissions, we also have 3 special permissions, which is the SUID, the SGID, and the sticky bit. Now when setting the SUID on a file, that would actually allow every time that file is being run to be run as the user's owner. So for instance, let's say this was a binary file and I set the SUID on this file. Anytime any other user ran the file, it would run it not as the username you're currently logged in as, but as the username that owns that file at the time. The SUID does not work on directory, so you cannot apply it on a directory. It won't do anything. The next special bit that we have is the SGID, which allows you to set a group ID. And that can be applied to binary executable files as well. So just like the SUID, let's say a user runs a file out of a folder that has the SGID flag onto it, the user would actually run the file as if they were a member of that same group. You could also use it to set default groups on a particular folder. For instance, let's say any file that's created by any user in the shared directory, I can make it so that file automatically has the group as shared. So currently, since for our user1 and user2, they had the primary group of shared already, so the default group that's created for each file is shared. But let's go ahead and open up a new tab and create another user, and we'll call this user3. So if I do ID on user3, you'll see that user3 is not a part of that same group. And if we look at the permissions on shared, you'll see that anybody that's not a part of the group or the owner of that file cannot read, write, or execute into that folder. So let's log into user 3 and give it a try. So if we do ls, let's say on the shared, permissions denied. Even if we had a file that's in there that's 777, for instance, let's go into our shared and we'll do touch test.txt, or let's just do another sequence of 50 into root.txt. I'm going to go ahead and change the permissions to 777. That means anybody can read, write, and execute that file. So let's try to read that file. Permissions denied. The folder actually superseded the permissions of the files within. So let's go ahead and add user 3 as a secondary group. Let's add the shared group as a secondary group to users 3. So I'm going to go ahead and do user mod -G, and I'm going to say shared is the secondary group for user 3. So now in order for those changes to take effect, we need to log out by typing exit and then log back in to user 3. And now if we do ID, you'll see that we are now shared, so we are part of two groups, user 3 group and the shared group. So now if we try to do ls-l, let's say, or ls on the shared directory, we'll have complete access. So let me cd into the shared directory, and I'm gonna use some command chaining and say touch a file user3.txt. So what happened here is I cd'd to this directory, and if this was successful, create the file within that directory. So let's do ls-l. So you'll see I have user3.txt. But notice the default group is set to user3. Let's say I wanted all of these files that are within this folder to automatically have the group determined for it as shared, the default group. But let's go into our root, and we're going to add a sticky, or not a sticky bit, but a SGID. So let's do ls-l. We're going to get out of there, and we're going to do chmod. First, let's look at the permissions on the shared folder, and you'll see that we have 770. So we're going to do chmod 770 on the shared directory. Now for these special bits, it's really a matter of just adding another number to the front. So if you remember the rule of thumb, 421, just think of the SUID as 4, the SGID as 2, and the sticky bit as 1. So if we want to apply the group ID, we would do 2770 on the shared. And if we did ls-ld on shared, you'll see that now we have read, write, execute on the owner and read, write, execute on the group, but with this little S bit now, which lets you know that the GID is now set on that directory. So now let's go back to our user 3 tab, and let's create another file called user3-2.txt. If we do ls-ld, you'll see that the new file that we created is actually owned by the group shared by default. So now let me go ahead and try to remove a file. Since I have read and write access and execute access to this folder as any of these users, user 1, 2, or 3, that would mean that I can also delete files. So let's say I wanted to remove user 2's file. I could just do rm-rf on user2.txt, and the file would be gone. But let's say I didn't want users to be able to delete any files that they did not create themselves. Going back to the root tab, we can set the sticky bit permission on the shared directory. So remember, we did chmod 2770, So let's say we wanted the GID and the sticky bit. So the SUID is 4, the SGID is 2, and the sticky bit is 1. So we would just do the 2 plus 1, which is 3, on the shared, which would now give us the ls-ld on shared, and you'll see that we now have the sticky bit enabled. So let's go back to user 3, and let's try to delete user 1's file. And you'll see the operation is no longer permitted since I am not the actual owner of that file or the directory that I am in. But let's go ahead and take a look at who owns the directory, user 1. And let's go to our user 1 tab. And let's try to remove the users3-.txt. You'll see that I was able to remove it because I am the owner of the actual folder, the directory itself. So that gives me full permissions. Let's log into root. And let's go into our shared. And let's try to remove user1's.txt. You'll see that the root user actually supersedes the permissions as well, because the root user has special permissions. So we talked about how to change the group owner, change the file types owner. We also talked about how to set permissions, change permissions, the special bits, the SUID, SGID, and sticky bit. So that wraps it up for this lesson on permissions.